Welcome to the Stormsurf video surf forecast for the week starting Sunday, November 22nd. First up, we take a look at significant wave heights for the North Pacific Ocean. The main area that pops out is this gale, just shy of the northern dateline region, right here south of the Aleutians, seas in the 36-37 foot range, and very well to the north, pretty much shadowed anywhere in the San Francisco Bay Area, but otherwise respectable, not huge in coverage, but producing a little something. Cut off low here north of Hawaii, not doing a whole lot. Remnants of a gale, still producing 16-foot seas in the northeastern Gulf of Alaska. And then Typhoon 27W here south of Japan or east of the Philippines and on a northwest track, but it has already peaked out. That was yesterday with winds in the 110 knot range. Let's dive into the details. As usual, first we'll talk about jet stream level winds. These winds are pretty much the source of everything, both in the North and the South Pacific, and anywhere on the planet for that matter, in terms of storm production. It is strong winds in the jet stream forming a trough, that is a dip, sort of like that there, that helps support gale formation down at lower levels of the atmosphere. Remember, the jet stream's up at 30,000 feet, pretty much the level that jets fly at, and again, these winds, when configured correctly, help support the formation of gales and also help direct their track. Right now, we have a very split jet stream pattern. Right here is the split. You can see it plain as day. Half the jet heading north, half of it heading south, and then just a fragmented mess east of that split point. That is not conducive to gale development anywhere in this region. But right here, like we said, we have a little bit of a trough, and there's some winds, not very much, but what is that? Oh, about 160, 170 knot winds, trying to support gale formation there. And as we saw in the previous image, there is a little bit of a gale in this region producing seas. This is not an El Nino pattern. Nowhere near it. But I'll give you a little hint. As we work our way through these images, you'll see something that looks a lot more like El Nino. Anyway, so we get into Monday. The trough continues to work its way to the east, right over the dateline. Notice winds start building here, building a little bit more, and the split point starts working its way to the east. Now, the reason the jet is all split here is because the inactive phase of the MJO has been in control. The Madden-Julian oscillation, a periodic oscillation that runs about 3 to 4 weeks on and 3 to 4 weeks off, has been in this sort of funk, been in an inactive state, which is kind of unusual during a strong El Nino, but nevertheless, it's been there, and that's just really sapped all the energy out of the jet. The sense is the MJO is starting to round the corner and move towards the active state, and let's just see how that affects the jet stream. So this trough continues east into Tuesday, into early Wednesday, falls apart, starts pinching off. But notice, winds start building here, and notice the split point in the jet stream continues to work its way to the east. So we get into Wednesday night, and here comes another trough just shy of the western Aleutians, building winds under it. Also notice there's this little backdoor trough here. We'll actually go back a little bit. So here we go into, even Monday night. It's really a just a tiny little trough, but it sort of tries to get some traction over the Pacific Ocean. Not enough, not in terms of forming gales or anything like that, but maybe a bit of a weather producer. And typically this configuration pulls cold air from Alaska down the U.S. West Coast. So even if you have a modicum of precipitation and moisture in the air, that cold air being very dry will just wring every bit of moisture out of the air and deposit it, typically in the form of snow at higher elevations, and that's exactly what we want to see a lot more of. Anyway, so then we get into our trough on Thursday. That builds, notice winds here, much stronger, coming off of Japan and consolidated here. A little bit of a ridge, a little dot there of 190 knot winds. That's exactly what we want to see. And then look at this trough just continues into Friday, moving into the western Gulf. Good consolidated jet stream flow, 170 knot winds, 180 knot winds even here, feeding into the trough. That will form a good counterclockwise circulation both aloft and down at the surface. That is low pressure, exactly what we want to see. And now here we go, another secondary low, and also a little bit of another backdoor trough on Saturday, trying to form off the U.S. West Coast. And then we get, and here is the classic part. Now just watch this. See how this was kind of a ridge here, ridging to the north. That supports high pressure down here. But watch how this axis tilts supposedly as we get into Saturday and starts flattening out. Look at this. On the 35 to 40 north degree latitude line, we have 170 knot winds consolidated from Japan the whole way to a point north of Hawaii. That is as of Saturday night. And then we get into Sunday, and look at that, just right down almost at 35 north, consolidated, not particularly powerful, but this is like classic El Nino sort of, or at least strong winter storm, active phase kind of configuration, with the split point reaching now to 140 west, and good energy still making it into the U.S. West Coast, even down to Southern California here. And then there's the last frame. This is exactly what we've been waiting to see. This suggests that the active phase of the MJO is coming to the forefront. The inactive phase is fading out, and this will give the El Nino base state exactly what it needs to wake up, come to life, and start doing its magic. If, and that's a big if one is going to believe the models that go 180 hours out. We don't believe any of it, but this has been on the models, both the long-range models that were run out 2 weeks, that was a week ago, and now a week out, so still some flavor. The details, very sketchy, but this is a very good sign, at least in the upper atmosphere. Let's drill down to the surface. All right, so here we are. Surface level pressure, millibars, like a 1020 millibar high here off the U.S. West Coast. And of far more interest, what is that? Hard to tell exactly what it is. We'd have to count it out, but let's say about a 976 millibar low in the Gulf of Alaska. Actually a storm, because there is a sliver of 55 knot winds and certainly 50 knot winds, and the Aleutians are right like that, and they are south of the Aleutians. Those winds are getting traction on the ocean surface. We saw, like, what was it, 37-foot seas being generated by these winds, aimed generally to the east, targeting the U.S. West Coast, but certainly some sideband swell towards Hawaii. Here's that upper level cutoff low, whatever you want to call it, 30 knot fetch, but it's all aimed off to the east. And then here's Typhoon 27W over here. And then another tropical system down here, not really doing a whole lot. We'll roll this out. So this system up here in the off of Kamchatka right there, heading into the Bering Sea on Monday and pretty much gone. High pressure 1036 millibar takes over the Gulf of Alaska, but remember the backdoor trough we were talking about. There's a little bit of low pressure, high pressure here, the two of them. So the high circulates clockwise, the low counterclockwise. When the two of them get close together, you get a thing called a gradient, a strong difference in pressure between the two, and that creates wind, north winds, 35 knot winds here on Monday night, falling south, and that's going to create a fetch. Now, for the most part, this is for the Pacific Northwest. Relative to California, maybe from Cape Mendocino or northward, good exposure, but south of here, it's pretty well shadowed, extreme north angle. But a weather producer is more what we're interested in, and another low-pressure system developing Tuesday off Japan as the jet stream starts strengthening there and a trough starts building. Roll this out a little bit more. We're into Wednesday or so. Our low here off the U.S. West Coast continues to fall south. Another low pressure system, really it was remnants of what was up here, tries to reorganize again. It'll get a little bit of traction. This guy already has a tiny area of 50 knot north winds on this Tuesday night into Wednesday. Here we go. Oops. 55 knot winds aimed well at Hawaii from this one on Wednesday. This, there's a lot going on in short. And then another tropical system developing south of Cabo, supposedly, on Wednesday. Again, we're into Wednesday, and this, here we go. 60 knot winds on Wednesday night as we approach Thanksgiving, moving over the date line. Not a huge system, but solid, aimed good anywhere from Hawaii up into the U.S. West Coast. Another low pressure system developing here. Tropical System 27W supposedly still stalled down here, but if you go look, and we'll just do a quick little diversion here. So here's the official forecast for 27W. It peaked out down here at about 110 knots. Currently right here, 95 knots. Forecast to make the curve, start accelerating on the 27th and just racing off with basically tropical depression storm status. The GFS doesn't even show that. And you can watch it down here as we roll through this. Yeah, it actually is. Actually, it had early runs had it stalled down here. Now it is shown tracking off to the northeast. That's a good sign. Anyway, so we're into Thursday. Our storm still looking very good. 55 knot winds. Another tropical system over here. And basically, this is a great looking pattern. And of course, supported by a good or building jet stream flow aloft. Anyway, roll this out. Winds continue into Saturday. Here comes the next system, 45-knot winds, not as strong, working its way towards the dateline. Good coverage, though, and we'll just roll this out, and you can sort of get a sense of what's going on. In all, a pretty active pattern forecast with the jet stream now down right here. You can see the storms are starting to, at least theoretically, are to track further south. This is great for both Hawaii and the U.S. West Coast. As long as the fronts don't start dragging over Hawaii, then you get bad Kona winds and conditions start falling apart. Likewise, if it gets too far south and the split point works too far to the east, the good news is you get weather into California. The bad news is you get weather into California, and not so good for surf, better for snow production and water precipitation. So let's just get to it. What is the effect of those winds on the ocean surface? Well, we saw this image already, the cutoff low, remnants of another low, the current developing system over the northern dateline, and our Typhoon 27W. 34-foot seas, maybe 35-foot seas here. Supposedly 41-foot seas in this system here. Maybe. I don't know if I'd believe that. Anyway, we get into Sunday night. Just looking here, right about there, looks about the peak of this one, and that is, probably about 38-foot seas. Now notice a lot of this energy is pushing up into the Aleutians. That's going to bypass any tracks to Hawaii for the most part, a little bit, but mainly more for the U.S. West Coast. And you can see that better on this image. See here, look at the swell vectors here, and look at the Great Circle paths into Hawaii. They're going 90 degrees perpendicular to the Great Circle paths. That means not very little energy moving down towards Hawaii. Relative to the U.S. West Coast, though, you can see they're pushing almost right up this, what is that, about 308 degree path? No, actually it's about 307 down here to 306 into Northern California. Probably a bit too steep for Southern California. That's, about 310 degrees or so, pretty much shadowed by Point Conception. Anyway, back to this image. So this guy, Sunday night, he pretty much moves, the core of the storm moves up to the Bering Sea, and that's the end of that. Remnants will work its way over here into the Gulf of Alaska. Here comes that new little system we talked about, the backdoor trough, if you will. What is that? 24-foot seas, but shadowed. Check this out. And here you go. This is the 315-degree track relative to Northern California. After that, once you get, this is really the San Francisco Bay Area, Point Reyes, shadow north of there, completely shadowed, but a little bit of energy perhaps working its way in there. And then we keep moving here. Another little gale tries to get going here in the Gulf. Notice all this is pushing to the north. It is this fetch down here that be aimed at California. Also, remnants of the backdoor trough again. And then this guy, next system gets going. Here we go. We got 22-foot fetch right in here aimed at Northern California come Wednesday night. Our new system gets going with 38-foot seas, and it builds significantly from there. We're into the 47-foot range. 47, about 48 feet here by 18Z on Thursday. So while you're having your turkey dinner, we'll have a good solid storm on the North Dateline region. But again, this guy's going to be well to the north. For the most part, shadowed down in here. Still, I mean, swell will get in. Long period energy for sure, but just the buoys will make it look way bigger than what will actually occur in the Bay Area. Our new tropical system supposedly pushing towards Baja, but that's also in some wind, barely in the window probably for Southern California. And we'll roll this out some more. That system continues to work towards the western Gulf on Friday, fades out, a tropical system inland, and here comes the next one on Saturday. Not as strong, 32, 34-foot seas maybe. There we go. This is the latest update, the 18Z run. It's making it stronger now, showing it stronger at about 39 feet, almost 40 feet coming over the dateline. Again, but 174 hours out. I wouldn't believe any of that, but this is good, aimed both at Hawaii and the U.S. West Coast. The point being on all this, we saw what the jet stream was doing. We see what the storm pattern looks like. Looks much more favorable than what we've seen, assuming all this plays out. The models have been overhyping stuff a bit, so give it a couple days, but let's say by Wednesday or so, we'll have a much better sense of what's going on. Let's go take a look at the long-term projections now. And by long-term, we're talking the major influence, the strongest of all, El Nino, and this one for 2015 being a very strong one. And we'll do this like we have in weeks past. We'll do first winds in the West Pacific, equatorial West Pacific. We call it the Kelvin wave generation area. We're not so much interested in Kelvin waves anymore. Not that we aren't interested in them, but just that at this point in time, any additional Kelvin wave production would be great, but it really won't do much because the bulk of it in terms of imparting energy to the atmosphere won't happen until we're basically late in the winter into spring, and by that time it hardly matters. Anyway, so what we're looking at right here is actual winds, and we see basically a slack wind pattern here. Certainly nothing that would make us jump up and down. Certainly no easterly anomalies. There are, of course, strong easterly winds, trades typical in the east equatorial Pacific. But here, the anomalies differences from normal for this time of year, a west anomaly wind pattern. That means that just a slackening of trades in this region allows warm water, like 30 plus degree warm water that's sitting here, that's actually migrated. Normally it's way off here. It's already migrated to here by previous westerly wind events, is continuing to move to the east. And what happens if you get enough west winds, that takes this warm water, moves it to depth in the form of a Kelvin wave and pushes it east. We'll get into that more in a minute. Anyway, so west anomalies currently in play. Let's go take a look at some forecast data. But before we do that, a quick look, just the past couple of days, 850 millibar, this is up about 4,500 feet. Wind anomalies, a little bit of a retrospective hindcast, if you will. The Kelvin wave generation area from about 130 east to about 170 west, and just a couple of degrees either side of the equator. And right there we see small area westerly anomalies on the 16th, the 17th, kind of faded out altogether here on the 19th, trying to regroup a little bit on the 20th, but basically a very weak, it's no easterly winds, but just a very weak westerly wind pattern. Also notice here, right in this area, it's a little bit north of the equator, but westerly anomalies also in the East Pacific, and that would be also very much typical of El Nino. And if anything, we would expect to see this region right in here building as we get deeper into the winter, more westerly anomalies there. So here's another way to look at it. Here's the Kelvin wave generation area, the core of it here, 3 degrees north and south of the equator. This is the far west Pacific Ocean. The date line is here, New Guinea here, and then 5 degrees out here, the dotted line, north and south of the equator. Current pattern, basically a light wind pattern. You see no trades, no strong, like 12 or 15 knot easterlies, just light wind pattern. We'll just sort of roll this out and just watch, nothing really happening. A little bit of westerly winds popping up here and there. Then come about Wednesday, notice this. You start seeing this westerly wind. Now, it's not in the Kelvin wave generation area, but it starts building and starts working its way northwest winds here into the southern Kelvin wave generation area. We suspect this is a forecast tropical system developing near the date line and then building westerly anomalies into the Kelvin wave generation area. This would be another sign that the active phase of the MJO is getting a foothold. Also, the fact that we have Typhoon 27W and the system, I think it's called Rick, off of Baja. Those are all signs that the inactive phase of the MJO is fading and the active phase is moving in. Exactly what we want to see as we move into the core of our El Nino cycle here, and then building westerly winds. These aren't anomalies, these are winds, and these are winds at roughly 16 knots, let's say, in this area. That's pretty respectable indeed. That would be pretty strong anomalies. And then that rolls out into about Sunday and then slowly starts fading off. But look at this. You have westerly winds pretty much from the equator south over the entire Kelvin wave generation area into Sunday night, and that's a good sign. We've seen this chart before. Current time going to the future. The Kelvin wave generation area runs roughly a line going down here to about somewhere over in here. The reds are westerly anomalies. These are easterly anomalies. This was our inactive phase of the MJO setting up, and it finally worked its way into the Kelvin wave generation area right about October 31st on Halloween. Now, it didn't do a whole lot. I mean, we still had westerly anomalies, but it basically shut down the westerly anomaly machine. and then slowly, little bit at a time, westerly anomalies have been trying to build back. Here's the current forecast. Again, over the next week, it's not showing as clearly the westerly anomaly pattern as what we saw in the GFS, but come about the last 3 days of the week, it shows it quite clearly here. Easterly anomalies being held at bay, but this is typical. You see easterly anomalies over the far west Pacific and westerly anomalies in the dateline region or so. Classic El Nino. We just want to see it a bit stronger, not in terms of Kelvin wave generation per se, but really westerly anomalies in this area also feed the jet stream. And that's what we're looking for, because that helps support storm production and, of course, surf production. And we've seen this chart before. Now, this is the same style chart as what we just saw, but here is current, or the past, going to current, and then future. And again, Kelvin wave generation area runs a line right up about here, down to somewhere over in here. The oranges and the yellows are westerly anomalies, blues are easterly anomalies. So here's that pattern. We're going back into September. Well, in October, we had a very strong westerly wind burst. That created Kelvin wave number 4. And notice we had easterly anomalies here. Basically, these were almost in the Indian Ocean, but again, and over the maritime continent. But again, that same sort of pattern. If we look up here, basically the same thing going on, just westerly anomalies not as strong. It really doesn't need to be. Anyway, but let's overlay the MJO. Here we go. We had a active phase of the MJO that was in play in October. That worked, or what they call constructively interfered with the El Nino base state, made stronger than normal westerly winds, and of course created a Kelvin wave. We've now been through the inactive phase of the MJO, and you can see clearly westerly winds died out. Now here we are. The inactive phase of the MJO is basically going to fade sometime over over Thanksgiving, and then we move back into the active state of the MJO. Westerly anomaly-wise, as long as we have anomalies, that's good. This would be the prime window somewhere between here and, let's say, into mid-January. This to support the jet stream, and then for storm production. Supposedly a little dead spot here in January, and then the active phase comes in again. We can also overlay some equatorial Rossby wave activity on top of that. That also supports westerly anomalies. You can see the integration here of the active phase of the MJO and equatorial Rossby wave, and you get a little pocket of stronger winds there, also there, also there. And then, of course, the low-pass filter. This is your El Nino base state. It peaked out supposedly November 1st or 2nd, but is still basically steady and supposed to hold steady well into February. No big surprise there. So basically, we're on autopilot now. As long as the MJO stays in some sort of active state, we should be home free. The jet stream should start raging. As we saw predicted a week out, the jet stream's supposed to pull itself together as this inactive phase of the MJO fades out, and then we should be open for business in the North Pacific for storm production for basically the rest of winter. And yet one more way to look at it. Let's beat the horse dead completely, because that's what we like to do here. Actually, you look at all the different models. They all have a different flavor of the picture to tell you, and then you sort of try to draw a line between all of them. It's not too hard to do right now. So this is the statistical model. The oranges and the yellows are the inactive phase of the MJO. It's really more sunlight reflected off the ocean surface, and of course the inactive phase of the MJO sort of supports high pressure, if you will. And of course, clear skies. The active phase of the MJO here, more storm production, less reflection. And so this is the situation we're in right now. Active phase in the Indian Ocean, inactive phase over the West Pacific. But what's happening over the next 15 days per this model is the inactive phase is supposed to get weaker, and the active phase is supposed to work its way into the West. We don't believe that at all. The dynamic model has a much more what we'd call typical pattern of what happens during these sort of things during El Nino. The inactive phase just fades out. The active phase fades out. The MJO in total disappears, and then the El Nino base state takes over 15 days out. So that would put us into somewhere around the first week, late in the first week of December, we should be fully in business. And yet two more models, the GEFS and the ECMF. So these are phase diagrams. Again, they are plotting where the active phase of the MJO is. Right now they're saying it's in the Indian Ocean in both cases. And as you get closer to the center, that means basically it's supposed to crash. So the MJO is not supposed to make it over the maritime continent or to the West Pacific. It's supposed to basically go in here and just die in both cases 2 weeks out. And that's consistent with all the other data we're seeing. And that will enable the El Nino base date to take over exactly what we want to see. So we've talked about surface winds, and here in this chart, this is the West Pacific, this is the East Pacific. We've talked about winds up here. But what happens is those winds, when they're from the west, or even when they die, that allows warm water that's normally all pooled up here to start working its way to the east. Exactly what we're seeing here, 30 degrees centigrade waters. And again, notice there's a giant hole in the buoy array here. These little X's are sensors on the buoy anchor lines. There's basically an array of buoys going the whole way across the equatorial Pacific, thousands of miles. But all these, a bunch of these buoys are out, and so it's hard to know exactly what's going on, but this seems like a fair representation. 30-degree temperatures working their way to the east. You know, we really want to see this even push further to the east, this 28-degree isotherm line. That's sort of key of knowing how far east El Nino is pushing. It's saying 120 right now, and by El Nino, I mean the warm water associated with El Nino. Anyway, that's actual water temperatures. It's the anomalies, differences from normal for this time of year. So the date line is right here. And notice we have this giant pool of warmer than normal water, 7, 8-degree anomalies here in the East Pacific. So this is, I don't even want to call it a Kelvin wave because it's much larger and has more duration than a single Kelvin wave. What you get normally is you get west winds blowing here. There's warm water here. It takes that warm water, pushes it to depth, and forms sort of a blob that slowly works its way off to the east, hits the Galapagos, erupts to the surface, forms like a pool of warm water. The trade winds here catch it and then blow it back to the east along the equator. We have more than a Kelvin wave. We have basically a massive reservoir of warm water that's been sitting here and will continue to sit here for quite a while based on this is created by 4 different Kelvin waves, the last of which happened in the October time frame, mid-October. And that's probably the last Kelvin wave that's going to make its way. By the time it fully bleeds into and erupts over the Galapagos, it would be late in December, and then it would take another month to make it out into the Nino 3.4 region out in here. That would be late January. Another month or two for that warm water to really work its way into the jet stream, start having enough effect on the atmosphere to work it and change the global jet stream pattern. So you're talking into, we said late January, late March. By late March, it's almost too late by then. So what we're saying is we have enough warm water here already to last us all winter, to do everything it's going to do. That's when we say we don't care about west anomalies so much from a Kelvin waves perspective. We don't. We got a whole reservoir here. We're good to go. West anomalies now are more about just the MJO and the local effects they have on feeding the jet stream, feeding tropical moisture up into the subtropical jet in the North Pacific, and feeding storm production. So that's kind of it. Let's continue to do our analysis here on the warm pool, though. Here's a higher res view, different sort of modeling. It's basically saying the same thing. Look at this, all warm water anomalies. Normally, this would all be over here, and you'd have this cold water over here. Completely flipped reverse now. Classic major El Nino pattern. We've seen this before. We're down to picking at details. This little 4-degree finger picking up here, that's reaching to the surface. When we get into the surface analysis, we expect to see some very warm waters there. And actually, all this is right on the hairy edge of just coming up to the surface. Certainly 3-degree temperatures. That is 1, 2, 3, 4. 1, 2, 3, 4. Yep, 3 to 4 degree anomalies just all along this region at the surface, and that's what we are seeing, in fact. But still, a very healthy reservoir here. This is a mixture of Kelvin waves 3 and Kelvin waves 4 sitting here. There's some interaction going on, we suspect, and we'll talk about that in a moment. But basically, a very, very healthy picture. And again, the November 14th image, this is JSON-2 satellite data. It shows sea height anomalies, differences normal for this time of year. Strip out all the waves, the tides, wind chop, everything. And what you notice is there's this big bulge here sitting right under the equator. There's Mexico right there, date line here. And what this means is when you have warm water at depth, warm water expands, it pushes the surface water up a bit. So you have a bulge, this is very large bulge too, 20 centimeters, and the satellite is incredibly accurate down to about a centimeter or two. So all this is saying is what we saw in the other pictures, lots of warm water, very warm water at depth here. Now compared to the 97 El Nino, the temperatures that we're seeing under here are not as warm as 97. 97 had good solid giant pocket of 8-degree anomalies. We're seeing 6, maybe 7-degree anomalies under here, so not as covering as large an area or as warm, but still very impressive nonetheless. And another way to look at this is upper ocean heat anomalies. We love this. This is back in December 24. You can actually watch the Kelvin waves working their way across the Pacific. One late last year about this time. Upwelling phase of the Kelvin wave. You get gurgling up of cool water between Kelvin waves. And then one in March, one in May of this year, and then the strongest one we thought, which was just off the chart. We go, wow, and notice the upwelling phase here started to develop. This is from a large westerly wind burst that happened over in here in the late June, early July time frame, 2.5-degree anomalies. And then here we are now with Kelvin wave number 4. And again, we talked about this. The width at any point in any single line across here was about 25 degrees, 10, 25. Now look at this baby here. Here's 10, 20, 30, 40 degrees. Here we are today from 42, 10, 20, 30, 40 degrees. So that's 2,400 nautical miles of 2.5-degree or better anomalies in this area. And that's looking at the entire column from 0 degrees depth down to 300 meters. What is that? It's like 900 feet. That's a lot of warm water. So this Kelvin wave has yet to erupt, and we'll qualify that a little bit because we have some thoughts around that. All right, so we've talked about westerly winds in this area, or westerly anomalies, that take warm water that's normally here, push it to depth, it travels under the equator in the form of a Kelvin wave, hits the Galapagos Ecuador region, erupts on the surface, creates a warm pool that then gets caught by trades that are blowing from the east and pushes them off back to the west. The main area that everyone monitors, NOAA, is the Nino 3.4 region. Nino 1.2 region is right here, right around the Nino 4 runs from about here out here somewhere. But and then Nino 4 goes from here on out here, but it's the hybrid of Nino 3 and 4, which runs from about 170 to 120 and 5 degrees north or south of the equator. They measure the total average surface water temperature in that area, and if it exceeds 0.5 degree for a month, then they go, okay, we got a weak El Nino. And if it continues and it continues, then you have different varying degrees of El Nino. If you're up in the 2-degree above normal range, you have an extremely strong El Nino. Anyway, the pattern, what we're trying to say here, very, very clear El Nino pattern. The oddball thing about it is it's not so warm right around here. The 97 El Nino was extremely warm in this area here, the Nino 1.2 region. Instead, we're sort of westward displaced. We have more warmth out in here than over in here comparative to 97. Compared to 82, maybe similar, I guess we'd say, to 82. Hard to say. 82 didn't, we got to see where this thing goes over the next 2 months. But for right now, we're somewhere, we think, between 97 and 82, which means that we're probably in super El Nino status, but we can't say that till we get hard readings because a lot of this warmth didn't really start happening till this month, November. Now here is the high res. The previous image we looked at was a 50-kilometer fidelity. This is 5-kilometer, much higher resolution. The point being here, look at this. This is all 4-degree anomalies, and the Nino 3.4 region is from 120 to 170 right out here. And we have not only 4-degree anomalies, but you can see pockets of 5-degree anomalies here. Very impressive indeed, but not a whole lot going on over here. We're kind of wondering, even though Nino 3.4 is the main region, it is in our estimation, the total volume of warm water, no matter where it is, as long as it's somewhere east of the dateline, that has the ability to reconfigure the jet stream pattern globally. 97, 98 Super El Nino had lots of warm water here, not so much out here. We have more out in this region comparatively. It's a different sort of El Nino, so it might have some slight differences in how it affects the U.S. West Coast, how it affects the storm track. We suspect, if anything, it'll sort of put the core of storm production a little bit further away from the coast, which is good surf-wise. You don't want the storms right on top of you because then it's just a big choppy mess. It might not be so great for Hawaii, but again, this is more idle speculation. We're kind of in uncharted territory here, so everyone's sort of guessing, and this includes some very brilliant minds from NOAA they're trying to sort of work their way through this and understand the impact. But here is the picture. Let's dive into the details. So we'll just go real quick here. Here's the current, this is zone by zone. Nino 1.2 region here, you can see 2-degree anomalies. Here we were a week ago, so things have actually rebuilt a bit, and that's good news. Not also up in here as well too, not that that's really in the Nino region, but just generally the more warm water here the better as far as we're concerned. Then we move out to the next quadrant, out from about 100 out to 160. This is where we see those warm vent ports where the Kelvin wave down below and that reservoir is starting to finger up towards the surface with 4-degree anomalies. Now, this is current. A week ago, notice that it was warmer over much farther to the west. It has sort of fallen back now and more concentrated here. That the suspicion is that the Kelvin wave number 4 is probably interacting with the warm pool and sort of pushing it a little bit, and it's sort of Kelvin wave number 4 is becoming integrated with the warm reservoir, and as a result, because there's so much warm water at depth, it just squeezes it out to the surface. So first it started squeezing it out here as Kelvin wave number 4 worked its way to the east, and now it's a little bit more focused here. The thought is, will it actually work its way into Nino 1.2, or is this about as far west as it's going to go? I don't know. We'll see when we get there. And then likewise, the last little segment here out to the dateline. Very warm waters here, but here's where we were a week ago. It was actually, we're splitting hairs here, maybe half a degree warmer right out here than it is now. But also notice that what was warm in the cutoff here before it got to the dateline, now those warm waters are reaching to the dateline and over the dateline. So it's sort of 6 of one, half dozen of another, just an incredibly warm pattern. Let's take yet one more look at all. So we put all that together. Now we're going back a week. Here's where we were a week ago. We were incredibly impressed with this because look at this. You went from 100 west to 142 west, and it's almost continuous 4-degree anomalies with little tiny pockets of 5-degree anomalies in there. But then you get to this week, and doesn't go so far out here, but look at this. It's much more aerial coverage here, and now we have building areas of 5-degree anomalies here at about 102 west and about 110 west. Just variance on the same thing. All this warm water is going to get caught by the trades, work its way into the Nino 3.4 region, and the monthly sea surface data for Nino 3.4 we're expecting to be incredibly impressive. Anyway, the picture speaks for itself. Not a whole lot of warming here, westward displaced, but very warming here. So we played a little game. The game was who's stronger, 97, 82, 83, or this year? And it's not based on temperatures in the Nino 3.4 region. It's based on the total temperatures in Nino 1.2, Nino 3, and Nino 4. Do a weighted average because they cover different amounts of territory and figure out the total volume of warm water, figure out what the number is, and see where it compares. So we started with the OISS2 data weekly, and here's where we came up with. Now, 97 for this point in time was slightly higher, and we're talking, what is that, 0.2 of a degree? And also note that it's probably a little bit higher, and this is biased a little bit on the low side or or our current data is a little bit on the high side, however you want to look at it. Anyway, so we are in close proximity from the weekly data. Then using the monthly data, and we were able to pull in the 82-83 El Nino, and here's where we are. This is weighted average, so we're not so much picking, no one else is using this data. We just did this on our own kind of analysis. But anyway, 82 versus where we are in 2015 versus 97. This again puts us right in between the two of those. And then the ERSST V4, which is even more conservative, and it has more data. So again, basically the same picture. And this is exactly what all the other data we're seeing is telling us. What we really wanted was the ERSST V4 centered data that takes all these older El Ninos and sort of calibrates them based on climatology, the current climatology. So we're really talking apples and oranges. The point being, the oceans have been continuing to get warmer in 5-year increments. And so these guys down in 72 would actually be warmer than and same with 82, a little bit warmer. But what we're trying to get a sense is, where are we in the super El Nino realm? And the thought is, I think we're pretty darn close. This is very much similar. The point we got out of this was, using this technique is the same as just looking at Nino 3.4. There's really no difference. We think the footprint or the impact on the jet stream is going to be the same no matter what. Anyway, back to November 21st. This is differences for the past week, and we've pretty much been able to surmise this ourselves. Most of the warming is happening west of the Galapagos, right here between about 100 and 120. This is the trend. So the greatest warming is happening here. Otherwise, we're pretty much, neutral or not getting any warmer, but really not getting any cooler anywhere else. And then a quick look here. Temperature trends in the Nino 1.2 region, and you can see pretty much we've had our ups and downs. Nino 1.2 is not considered when calculating where you are in El Nino, but it's sort of a gauge we use. Now we're at about 1.9 degree anomalies. Nothing really impressive here. But here is the impressive pictures. So earlier this week, we got into the 3 degree, just a shade over 3 degrees above normal, which is incredibly warm. Again, these are daily values, and we've dipped off a little to 2.9. Oh my gosh, that's such a huge dip, and we're kind of joking here. These temperatures are incredibly warm. The point being here, if you go back to, about October 9th, there has not been a single daily reading below 2 degrees above normal. And one can arguably say, even back into the whole range here, yeah, we're steadily here about 1.9, but then we got these blips above. We've been in almost the 2 degree range since, about mid-August or so, August 21st. So what's that, 3 months worth of data? So, if you were to take an average right now, you would say, okay, we're probably somewhere, just eyeballing it, 2.2 degrees above normal. For a 3-month average. Now, this is biased a little bit on the high side. But let's say even 2 degrees. If that were the case, that means we're pretty much in super El Nino territory, but we're not going to declare that. There's all kinds of little math variations and climatology variations that go on here. We want to see the November data. We'll start there with a 1-month average, but the thought is the whole month of November is incredibly warm. There's enough warm water down there and the interaction with Kelvin wave number 4 that the December data should all be in the 2.5 to 3 degree range as well. And we assume this is biased a little bit high, but certainly October, November, December should put us very, very close, somewhere between 82 and 97 is our guess, which would put us in super El Nino territory. The kind of head scratcher thing going on is, why is the inactive phase? Why did it happen at all? Why is it there? It shouldn't be there during super El Nino. But the plus side of that is, well, if the inactive phase is there and it's having effects, when the active phase comes in, which it inevitably will, it'll have just that much bigger of a positive effect, and it's going to do it into the December time frame, right when our El Nino is peaking out. So that's maybe actually a good thing. So you can kind of go back and forth on this. Hard to say. Either way, we're sort of splitting hairs. We are in very strong El Nino territory. We're going to move really fast here now. Southern Oscillation Index. We're talking about the coupling of the ocean to the atmosphere. The problem is right now with the inactive phase of the MJO, it's kind of messing up all our indices, and it's hard to tell really how well things are coupled. A long run of negative numbers here in daily values, differences in pressure between Darwin and Tahiti would suggest the active phase of the MJO or El Nino. We're currently at plus 10. Pretty meager looking indeed. The 30-day running average is up to -6. It was down in the -20 or below there, and the 90-day running average is up to -14.6. It was down at -18 or 19. Maybe you can see some of that right in here, and here's your -21s or so. So we've taken a good hit here by the inactive phase. The good news is the models are saying that's about over. We'll see in the next week, but then all this should start dropping negative again. We want to see this guy peak out in about the December-January time frame. Graphically, here's the 30-day Southern Oscillation Index. You can see we've been on this downward run here in last year, but that was a failed El Nino. Now we're into this year. We've been just steadily dropping, but here we go. Inactive phase of the MJO. The numbers are coming up. We expect that to make a turnaround here shortly and start falling. The other index we've been looking at is the ESPI, but it's kind of late in the game for it. It doesn't matter. Normally the ESPI different, so it shows you differences. Actually, we'll just show you right here. Cloud cover region in the maritime continent versus over the Nino 3.4 region. Basically, you would expect more clouds over warm water, less clouds over cooler water. This number was up at about 2.4 a couple of months ago. It's steadily been rising, but typically the way this works is this leads the Nino 3.4 temps, and sure enough, 2 months ago, it was up at 2.4. Nino 3.4 wasn't that warm. Now here we are 2+ months later. Nino 3.4 temps are through the roof. This guy is falling back. He's an early indicator. If anything else, it's normal to see him die off. Otherwise, we have no other atmospheric coupling numbers that have updated this in the past week, so that's what we're going with. And then finally, sea surface temperature projections from the CFS version 2 model. This is NOAA's model, upgraded yet again. Peak temperatures, according to this, are basically happening right now at, what is that, about 2.85 degrees above normal. Incredibly warm, supposed to fall off. The PDF corrected thing, though, we don't even buy it. We go, nah, no good. Because we believe, yeah, maybe temperatures have peaked out, but they're not going to drop off like that. By the time you get to December, we're not going to be down to 2-degree anomalies. We don't think so. So we're going with the uncorrected version. This seems far more realistic. That says we're up at about 2.85 degrees, but that we're basically going to hold in some fashion out through the month of December, then start dropping off. And you go, oh, that's not good. Well, the reality is, remember, these temperatures only stay warm for a little bit of time, but it takes the better part of 2 months before the atmosphere to really respond in kind to these temps. So if you have peak temperatures in November, December, then you're not talking until, let's say mid to November. So you're talking January, February before the atmosphere reacts in kind. And if you have an active phase of the MJO going on in that time frame, which the models suggest, I mean, we should be in for and if temps are in fact coming in at the, even in the 2.2 degree range for a 3-month average, we're in super El Nino territory, and I think everyone understands what that means long term in terms of surf and in terms of precipitation potential. So to wrap it up real quick, the pattern is improving. Jet stream forecast to look very much like El Nino a week out. Storm pattern improving accordingly with a series of storms working their way off Japan. Small now, we want to see them bigger, but small now and consistent, working their way towards the date line. We're almost beginning to get the sense, and because of this westward placed El Nino, we're sensing right now that the peak storm area is going to be somewhere between the date line and the western Gulf of Alaska. Again, that will probably mean more poor weather for Hawaii, we suspect, and maybe not as poor a weather for California, and better potential for swell because it'll just have a little bit to unwrap. But anyway, El Nino, very strong, historically strong, developing, everything on track as we've expected. The inactive phase of the MJO is supposed to be out of here. That will shut down the negative interference or the destructive interference with the El Nino base state, and come about a week or two from now, we think we're going to be singing a much more positive tune, if we're not already, about storm production in the North Pacific. So we suspect it's all moving in the good direction from here. Hang on to your hats, folks. Anyway, there's surf, or there will be surf in the coming week or so. Go get some of it. Enjoy your Thanksgiving. We'll do this again next time, next week, same channel. See you then. Bye.